All right. First, I'm gonna ask you guys, and I'm gonna call on you. Like, I want your answer on this one or whatever. But then I want to talk about some things that are right or wrong, some things that are wrong but they will work, and why they are wrong. You know, the thing is in diagrams, if you understand how a circuit's supposed to work and why each one of the pieces of the circuit are in that diagram, then you'll understand when you're looking at it. Like I said, I tell people when I look at a wiring diagram, it's like me picking up this piece of paper or a book, and I can read all the words on here. But if I went to a kindergarten child and said, here, read this to me, they see the words, but they can't read all the words. But you guys as adults now, and for those who have reading issues, I'm sorry if you do, but for most adults, you guys just look at it, and within 30 seconds, you could read everything on this piece of paper. But you don't even think about it. And that's how you have to look at wiring diagrams. When I look at a wiring diagram, I don't just look at lines and switches and bulbs, but I'm understanding, oh, it's gonna run for this long until this happens, and when this happens, now it tells this to go, and that information isn't written on the diagram. It's just knowing, okay, this symbol is this part. I know how this part works, and so like a water level switch, for example. You got a water level switch in a washing machine. When we turn on a washing machine, what's the first thing a washing machine does? Fills up with water. Now let's talk about a top load washer just for this example. Is the motor running? No, it's a water valve, not a pump.
Okay.
Pump is to drain. Okay, so the water valve's letting water in. But is the motor running?
No.
Okay, what does the motor do in the washing machine, the main motor?
It's in needle.
Well, no, but what's its
It
function?
spins.
It agitates or wash, and it spins the clothes. That's the
Yeah.
main purpose. Some main motors also drive the pump, but the motor's not running. Well, why isn't the motor running?
It's not
There's another switch that shows the level.
The water level switch. So we don't want it to agitate without water in our clothes.
No.
The agitator will destroy your clothes in the washing machine if it's doing this without water.
Yeah.
So there are different parts in the machine and their function, like what they're supposed to do. When you look at it, you don't just look and say, ah, that's a water level switch. I know that any day it's a water level switch. But then the water level switch controls the water valve and the motor, and we'll look at it in the diagram and go a little bit deeper into that once we finish the assignment. But that is how and what we're looking for when you're looking at a diagram. We're not just looking at it, well, that's a switch. I know that's a switch. I know it's a door switch. I know it's on the door. Let's go a little bit deeper. What is that door switch for? What's the reason why the door switch is there?
Safety.
So the machine doesn't run with the door open, right?
Yes.
Okay, so then if I know that, I also know that, well, when I close the door, the switch has to be closed so the machine can run. When I open, the door has to be open. So in other words, I'm just looking at a switch, but all that information's here. So when you guys are working on the machines again, and you want to know the diagram, yes, it's important. 90% of people that go into this trade, they all want to learn to read this wiring diagram. So, but learning to read a diagram is knowing every little bit of information about the machine and the parts that it's representing. If you look at a symbol, no water level switch, know what that water level switch is there for, and the function of that water level switch. So when you look at the symbol is just to tell me power goes in on terminal 1 and goes out on terminal 3 to the water valve. If the water valve don't work, yeah, so I'm gonna check it. But how's the machine function? Well, right now in this position, it's filling with water. Once it fills up and goes to that position, the motor runs. This is the stuff you need to know. So when you're looking at the symbols, you understand the circuit. Okay, there's some more things we want to go over today. Forgive my typos. I got typos all over the place. But when complete a circuit using a single pole, single throw switch, and an incandescent bulb. So in this case, I asked somebody to do that. So a single pole, single throw switch, can be drawn like this. It can be drawn like this. It can be drawn like this. It can be drawn any one of those ways. It doesn't, there's no right or wrong way. But it's the overall shape of the switch. It's almost like, I was telling someone, oops, yeah, sorry.
It's a different example. Now it is.
What is that?
Looks like a stop sign.
It's a stop sign.
It's not.
Well, it's not red. It don't say stop on it, but you know it's a stop sign.
The square, the shape.
Okay, that's what these are here for. So we have a standardized method of drawing diagrams, but doesn't mean every manufacturer is going to draw it the same way. Why? Well, some manufacturers are in Korea, some are in China, some are in
Different people.
Europe, some are in Canada, Mexico, the United States, and most of these people, their first language is not English. So when they draw a switch, how they learned how to draw a switch in their country is how they're gonna draw it on a diagram.
Yeah.
These service manuals, Samsung has these great service manuals. You know how many times I've read the manual, didn't understand what it said because it was written in Korean and someone who knew both languages translated it, but their translation is more conversational and not instructional. And people don't understand what they mean. So again, shapes are important, but it's there just so we say, okay, I know what part that is, okay? So let's move on. So a switch and an incandescent bulb. An incandescent bulb can be drawn like this. It can be drawn with two circles, like this. It can be drawn sideways. I can even draw it upside down. It doesn't matter. It's an incandescent bulb any way you look at it. Okay? The dots, we only use the dots to help us understand that's where the wires from the machine are connecting to the part. That's what the dots are. Could they be solid black dots instead of open circular dots? Of course they could be. Okay? So I need someone, I'm a volunteer. Corey, you do the first one for me? Can you do this diagram here for me? Watch the cable there. You know what?
What's up, boy?
Some food in the oven. Lasagna. And salad in the apple.
There's a back arrow here to undo, that back arrow right there, hit it. And then you can correct it. Okay, perfect. Watch your step behind you. Okay, let's talk about this for a few seconds now. Did he do it correctly?
Yes.
Yeah.
Yes. Would I have liked it a little bit more like this? That's just being picky, okay? He didn't do anything wrong, okay? There's a couple of things here that I want to point out. First of all, the incandescent bulb. He did draw the circle below it. You know what? That'd be fine. I would understand that he's talking about a light bulb, but why do you think this line is going like this through that circle?
Line and load.
The filament inside the bulb, that line going through is basically representing that little filament inside. Just remember, a schematic drawing is an actual drawing of the part or a symbol of the part.
Simple.
A symbol of the part. So this is a symbol of part. A pictorial drawing would look like this. That's a pictorial, like more of a picture of the part. But if we had too many of these on this diagram, it would be too complicated to read because the parts would be so big you don't have room for all the lines. Okay? So these are good, but let me ask a question now. I'm going to clear all this stuff here. What if I did this?
Good too.
Will that work?
Yeah.
Yeah.
Is it right or wrong?
No,
Yeah, the light will always be on.
Is that right or wrong?
No,
it won't.
It won't be on because the switch is open, so there's no current flow.
Gotcha.
There's voltage at the bulb, which is what I'm leading to. That code, when you look at wiring diagrams, all of the switches are first, and the load is after the control. Why? For safety purposes. If I was to unscrew this bulb right now, like this, and it cracked, and I touched that film with my finger, I'm electrocuted.
Yeah.
Now, safety, unplug the lamp and unscrew it. But sometimes you have a light fixture in your house and you don't know which breaker it is, and guess what? You can't find it because the light don't work anyway, so you don't know if you turned it off. So you're unscrewing it. If they had the power go to the bulb before they go to the switch, then you could get shocked. That is the reason why, if you look at most diagrams, you're gonna see the switch or relay or timer switch or whatever. That's usually the first thing in the entire circuit. So it can control everything. All right? Now, if it's a 240 volt circuit, is one switch enough?
Two.
This is a 120 volt circuit, okay? Line one and neutral. Okay? So we said on a 120 volt circuit, we want the switch first and the bulb second. And that line one is the actual power. And if you look at an outlet like this, you got a small one and a big one. It's actually the opposite. The big one's usually on one side. The small one is line one, the big one is neutral. If I touch that, I get electrocuted. If I touch neutral, shouldn't get shocked. I'm not telling you guys to touch any of the wires now. But I'm telling you is that line one and neutral is in that outlet. So that's how we do polarity. Okay? Now, on a 240 volt, I asked a question. Is one switch sufficient?
No,
Why not?
because you need to cut, line one needs a switch and line two needs a switch.
That is correct. So line two is over here. We have to have a second switch on both sides because each one is a line of power. So we have to have a switch on both sides. The bake element in an oven. Back in the day, guys, most of you weren't around, only a couple of you were around. The element, one of the wires of the element went right to the power cord in the back of the stove. It's okay. I mean, you're going to change the element, you're going to unplug the stove. Well, we got these wall ovens here. And if the bake element don't work, you have to take the whole oven out to check it. Well, what we used to do back in the day is we took the two screws in the back inside the oven that held the element, and we'd pull the element forward, and we could check voltage or ohms on the element without taking the whole oven out to check it.
But wasn't that shocking?
But if one of them went right to the power supply, and I touched that wire, or that wire touched the metal oven liners as I pull it out, I'm gonna have sparks and customer, what happened? You blew up my stove and you blew the breaker. No, I just gotta reset the breaker. I didn't blow up anything, you know. And now you're embarrassed or you're injured. So when they first made the stoves, they didn't have this secondary switch. The switch on the surface element on a stove, how many switches control the element? Two, one on line one and one on line two. We'll look at that too. So again, knowing that in the circuit, knowing that the switch has to be on the hot side, and if it's 240, we have two hots that make 240. So we have to have two switches. And when we troubleshoot, we also have to think that way. That I gotta have power coming in here and power coming in here to make that work. Okay? So if I'm checking, I have to check power both ways, where on this circuit, neutral, there's no power here. This is where power is coming from. Understand the circuit completely. Let's go to the next one. Juan, you want to do this one?
Yeah.
Okay, complete the circuit using a momentary contact switch and a motor. Perfect, thank you. You guys, think that that's good, or have any comments on this diagram?
It's good, it's good.
Yes, sir.
You gotta have the line in the middle.
No. If he wanted to draw the motor like this, it's acceptable. Sometimes they'll put TM in the middle, what does that mean?
Time.
Timer motor. Back of your timer, little motor on the back of this timer, so it causes it to go around. They put TM to let you know, this is what they're talking about in the diagram, okay? Again, on a diagram, they got things called legends. We'll talk about that once you get a little bit better understanding of this and how the legends and all the different charts work, but we're gonna just start off with the basics. So when he presses that button, that motor's gonna run?
Better be
How long will it run?
until I release it.
So it'll only run while you're pressing down on it. It's like to push the start switch on a dryer. It only makes connection when you're holding it down. Well, that's no good. Give me an example where there is a switch like this connected to a motor in any appliance here. We do have a circuit like that. Not the exact same switches and whatever, but we have a circuit where the motor only runs when you're pressing down on it. Yes, sir.
The washer, it will be pressed to start. It will start.
But the button on most washers, when you're pressing, you're creating a connection to a control board. Now the control board program took over and it's running through a cycle.
You
Okay.
crank it.
Okay? In this case, this is a mechanical motor and power's got to get through that switch, that motor. But this is a switch on a dryer that only makes connection when you press down on it. When you let go, it's got a spring inside and it opens back up. So power can't go to the motor no more.
Is, for example, if I open the washer and I manually hit
Yeah.
I hit the
If you
button.
take your finger back out, it opens back up, right? It stops. So that's the thing. If I press down on it, it's closed. If I let go, it opens back up. Now this is a partial circuit to a dryer motor, but we have to have a secondary circuit to keep it running. I'm not gonna get into that today. But the point is what appliance in this class or in your home that there's a motor running when you're pressing down on a switch?
My blender.
No, appliance.
I'm sorry.
Your blender does have one button
No,
that's
but-
pulse, that it don't have high, medium, or low, but it's pulse and it only, yeah, you're right about that, but that's not what I'm talking about. Yes, sir?
Microwave?
No, because the microwave, you press start and the computer takes over.
Oh, okay.
And then we-
I would say the driver.
How about, yes, go ahead.
Toaster.
What?
Toaster.
No, toaster, no, because it's got to switch you to that. Guys. Have you ever taken a cup and went to a refrigerator and got ice?
Oh, wow.
And the ice motor runs when I got the cup, and when I
Yeah.
take the motor out, what happens?
Yeah, you tricked it, it's a trick question.
How's that a trick question? But,
That makes sense.
but no, wait a minute. That's how that circuit works.
Okay.
Now, maybe the switch is telling a control board that's telling it to run, and it's more complicated than that. But this is how that circuit would be used. That motor for the ice coming out is only running when you got the cup in here and pushing on the switch. When I take the cup back out, the motor stops.
So that's what you go back.
So that is
Yeah.
a good circuit, even though when most people look at it say, that's stupid because it's only running when you're holding it. When you let go, the motor stops. But then you're saying, well, if I know that information, that I understand how that switch works now, what that switch does, and I understand how that motor works.
I never knew that.
But that's where, this is where understanding diagrams comes in. You know, you know what? I didn't preconceive that statement of the ice. As we were talking, in my head, I said, oh, well, that motor's only gonna run while you're pressing on it. And then I thought, I'm thinking to myself, why would anybody wanna do that? And then in my head, it all of a sudden it just came to me and said, that's what happens when you grab for ice. The same thing when you grab for water, right? You put the cup, water comes in, but instead of the motor running, what do we have running?
Water gun.
The water valve. So then I'll go like this. and I'll change that circuit to this.
Of course.
And I press down on the cup, I get water. I let go of the cup, the water valve stops. Same idea. Does that make sense?
Isn't the same thing with a switch on a light switch in a refrigerator? When you open it,
Yeah, but when you open it, the switch closes, not when you're pressing on it, so it's an opposite thing, but I don't wanna get into that, but yeah, it's similar idea, but opposite. Cause when you press on it, it's not there. Alright. Come on, do this one. Try to pick some people I don't get to see up here often, you know? I got you inside these, but I'm giving you one more difficult ones, okay?
I thought you were gonna give me this one.
Why would I give you an easy one? I like you.
Oh, shit, this is
Ah.
Yeah, it is. Oh, okay.
Now just, you did it right, but let's just do this.
Mhm.
When you draw it, give it a little bit more up and down and up and down like that. Okay, make them bigger, like 4 of them, that's all. And that's it, that's perfect. What do you think about this one, guys?
Yeah, right.
Okay,
Or resistant.
we have a thermostat controlling the heater. This says heating element, but yes, it
Okay.
could be a resistor. A lot of times they'll put a resistance reading there telling you resistor, or they'll put a wattage reading, then you know heater, but resistors are also measured by wattage too, by the way. So, but let's take a look at this for a second. Will this circuit work?
Yes.
Yes?
Yes.
Let's just say this was in a room. This was a heating element in a room, right? In this case, is the room hot or cold?
It's hot
Hot.
How do you know?
because right now it's off,
Okay,
so it's cold then.
so it's cold. I'm sorry, could you tell me to read the diagram and do it?
no.
Yeah.
That, I wanna know what you're thinking, okay?
Right now,
I
from
need
what
that
it-
information.
From his drawing, it's showing that it's off.
Okay, it is off. So then when would it come on?
When the hand go down,
And what's gonna make the hand go down?
the push, I think this is the push.
temperature.
This is based on the temperature of the room. That's a thermostat.
Oh, okay.
This is a thermostat, but this is an adjustable thermostat. This is a refrigerator thermostat. Senses the temperature, got 2 contacts here, and inside of here is the same part as inside that diagram. But the only difference is this one's adjustable, so I put an air on an angle. But that's not the point. It's the temperature of the room.
Okay.
Okay, so, this is the first time he ever did it, so not a dig on you, bro. Thermostats, there's more information there that's going on. That one to me tells me it opens on heat rise. And I think of the hat. Okay? If hot air went in there, what would that switch do? It would open. So this one opens on heat rise. Okay, well, that means when the room got hot, that's the condition that thermostat would be in. I know all of that by the way it's drawn. But can someone come up here and draw below here the same circuit, and I'll go ahead and draw the lines here. Draw the same circuit
So he's with.
where it closes on heat rise. And let's see if you can get it.
Where it closes, right? So that when the heat falls.
That's open on adjustable. This said fixed, but otherwise that would work, where it's closed and when it gets hot it opens. The arrow at an angle.
I messed up the drawing, but it's.
That's not that close, but thank you.
Not that close?
But no, no.
And that's the symbol you talking about right there, right?
That says operate on temperature fall when it gets colder, but I want this, I'm gonna show you exactly what. So if you wanted it, if you, this one opens on temperature rise. So that means this one opens up. William, I know you're helping them, but I can't talk at the same time again, Drew. So when this gets hot, it opens. Well, I want it when it gets hot, it closes, but that's when it would energize the heater. So functionally, it's not work, but that same thermostat would look just like this. It's the same drawing here, oops, it's the same drawing here, but now it'll push it closed when it gets hot. Where this one opens when it gets hot. So I'm looking at it, it's open, but it being open, I know the drawing of it, what it means it's going to do without words. You see what I'm saying is like a symbol is more than just saying it's a thermostat. Because we have thermostats that open and close on temperature. We have thermostats that are single pole, double throw. We have a thermostat like this, and we have an arrow here to single pole, single throw, right? But if I put another one up here, I have a single pole, double throw, so it's making contact here, but when it gets hot, it goes here.
So, let me ask you a question.
Yes, sir.
How do you know which thermostat's symbol, because the one I did the single pole pro one from the one that you did. So how you know which one?
Yours being upside down was okay, you did it upside down, but you didn't draw it connected to the two wires properly where I could see the circuit. So like you did this, okay, here was the circle,
Yeah, you're right.
and it went like this,
Right.
and then I have another circle like that,
Okay.
where the opposite would be like this, and it would be touching like this. So when hot air came up, it would open. With this one here, when it gets cold,
They'll go down.
yeah.
Got you.
Okay, yes.
Why would you want to close the circuit when the heat is rising?
You wouldn't. But I just said, give me a thermostat and a heating element. So in my explanation, you would not normally do it this way because it would say it's open, but actually it's not wrong. Because when it's hot, it's gonna be open. So now, let's just say, okay, in 2 months, what's coming up?
Winter.
Christmas. It's usually, no, that's what I'm looking for. And usually, if I'm in New York, it's about 90 degrees in Christmas, right?
Right.
Really? 90
Christmas,
degrees?
no.
No, but, okay, so in New York, it's
Yeah,
freezing,
New York
right?
is cold.
It could be
Freezing.
snowing, it could be 18 degrees outside.
Yeah, New York is was.
So right now, it's 90 because it's summertime, okay, or fall. And as soon as it gets cold outside, this thermostat's gonna do what? It's gonna close and turn the heater on. And when the heater brings the room back up to whatever temperature we set it at, it's gonna open, turn the heater off. So this is a functional circuit.
So just
Because of
like
that situation.
Yeah, so
Yeah.
it's just like an AC, you just stop running the motor.
So, it has a function. This one is working, so when it gets cold, it'll drop and close, turn the heater on, and then when the heat comes here, it's going to open. This one here will not turn on the heater until it heats up, and then it closes. So this one here is the opposite way to draw it, but this is actually functionally correct, if that makes sense. Yeah, okay? That make sense? Any questions? You don't look like you're convinced, right? No, you're looking like, I still don't quite see it.
It's the context for when you would use it.
Well, in this case, let's just clear everything, okay? In this case, normally it would be like this, and the heater would be on, right? And I'll put the thermostat like that, for example. Heater would be on, heat up, and it opens, turns the heater off.
Yeah.
But again, we don't want the heater to run all the time in South Florida, right?
Of course.
No.
We only want it when it gets super cold.
Yes, you
Yeah.
are.
So, in this case, the thermostat is open. Let me draw a little better than that. This thermostat is open. And when it gets cold, it'll drop down but I'm looking for temperatures a lot colder than that for it to close.
Yeah.
So this one will probably open, let's say, at 80 degrees, because we don't want to heat up the house hotter than 80 degrees, okay? But then this one here, I don't want it to close until, let's say, 40 degrees. If it gets 40 degrees or colder in my house, I want it to close and turn that heater on. And then when it goes above 40, the heater goes off. So that is what it is. And those thermostats are going to have the temperature printed on them and tell you this cycles at that temperature.
Yeah.
But they will have like a dryer may say 140 degrees plus or minus 10. What's that all about?
Either below that temperature or above that temperature.
Yeah, it could be 10 degrees higher or
Fluctuate.
lower. What if they just say this? 140, and then I just put, I gotta look at it, let me look at it on an actual thermostat on the dryer real quick, because I don't wanna write it wrong, but this is another way that they'll do it. That one you can't see all the information on the top of it. Here we go. Let's look at the top of this thermostat here. So if we look at this thermostat, I think this one's probably gonna be a better image. Now they're showing you in Celsius here. They don't have it in Fahrenheit, but we can still talk about it. So that's L meaning the limit. That's the temperature that thermostat's gonna cycle at, okay? At 146.1 degrees, 146.1 degrees Celsius, and then it says minus 44.4 degrees Celsius. So what does that mean?
So if it go down,
If it
It's
goes down
less
what?
than freezing.
less than 44 probably.
No, remember, this is Celsius.
Yeah.
So 44 degrees Celsius is hot. 100 degrees Celsius is boiling.
Boy.
That's 212 degrees Fahrenheit. So
Okay.
40 degrees is about half of that. It's almost 100 degrees. I don't know the exact number,
Yeah,
but
32, yeah.
but here's the thing.
No, but 0 is freezing, and minus
Yes.
44 is.
Oh, I know. But I'm saying 146 minus 1.1 is the temperature the thermostat's going to open at. If you minus this from that number, which will put you at about 102 or 102 or something, that's where it's going to close back. So it's going to open at 144 Celsius and close at 102. So I'll explain
So
that.
that's for-
I'll explain that one
There
second.
is a range between them.
Yeah. So here, let me see.
Okay. Now it makes sense.
144 Celsius.
To Fahrenheit.
It's probably like 48 degrees or something. 291.
Yeah, that's right.
Oh, that's right. Yeah, because
Yes.
100 is boiling. So yeah, that's about right. That's about 50 degrees. Every 50 here is about 100 here. So that there, and then minus 44. Let's just say 44 degrees is how much? Is 111.
So that's how hot the dryer goes?
So it cycles there, but it comes down here. That can't be right. I got to look that up. But anyways,
Is it valid?
they normally only have 20 to 30 degree difference. In other words, it'll open here and then close 20 degrees after. So you take the average. If let's just say a Fahrenheit, it opens at 140 Fahrenheit and the thermostat's open. So what's happening to the heater? It's going to drop.
It start dropping.
So at about 15 or 20 degrees, it drops. The switch will close. The heater will come on. So it shuts off here and comes on here. It'll keep an average temperature in the dryer.
So what the average temperature usually a dryer is supposed to be?
On high heat, about 140 to 160 degrees.
So if it get too hot in the dryer, that's what cools it down.
That's what prevents it from getting too hot.
Okay.
But there are other things in there that could cause too hot. Let's go back to this. So
ever
you
had
guys
that issue?
understand that, what?
You ever had that issue, someone saying that their dryer is too hot?
Oh, yeah. Oh, I don't want to get too
Okay.
sidetracked from here, though. So You understand, like, again, this is where understanding more than just saying, oh, that is a thermostat. I know how it cycles. I don't know the temperature it cycles unless they give me the temperature on the wiring diagram, but I know how that part works. And if I went and said, well, what does a dryer thermostat look like? If I looked at my table, I don't have one on here, but usually I have it. I have a thermostat and I say, here's a thermostat. You know, I know that that diagram is that part. So your job on these diagrams, and I don't tell people as deep as I'm telling you guys, is know the symbol, know what part that symbol represents, understand how that part works, and understand how to connect it, and then also know that the controls have to be in front of the loads for safety reasons. You can put them reverse and the machine will still function, but you have the ability to have power here all the time at the load, which is not safe. Okay? Let's go to the next one. Francois, you want to do the next one? These are the simple ones. We don't do the bigger ones. You know Paul's going to do one of the heavy ones. No, make them big. Make them like sweeping. Yeah. Just like that. And go down. That's it. And that's not a fuse.
It's toasted.
A fuse is like this. Like a sideways S.
That's way off. Mine is way off.
That's just it. Well, you can use the eraser then too. Go hit back again. Keep going. That's all right. That's fix your. There you go. And then the fuse. Just a sideways S. Go up, circle down, all the way down, go back up, and that's it. Connect it straight into the wire. That's it. You're done. All right. So, is this a good circuit?
Yes.
Yes, it is. But there is something wrong with the circuit. Because I don't have a control, I only have a safety. What's the difference?
Well, I mean, what
If
is-
that goes off, it's gonna continue.
If it what?
If it goes off, it's gonna continually keep going, if the fuse goes?
What do you mean if the fuse, no, if the fuse goes bad, this is gonna stop working. You had,
Well, I was just gonna say, a fuse is meant to prevent something, and then the switch is meant to activate something.
okay, let me go a little bit deeper, but yeah, you said what I'm getting at is that a fuse is meant only as a safety to stop this from working, okay? But I have no way to turn it off. It would be running 100% of the time. A control is what turns it on and off. The fuse is to act as a safety. If this piece shorts out or gets damaged or something else touches it that it's supposed to touch, it's supposed to blow and say, stop working. So what does that mean if you go to a customer's machine and see the fuse is blown?
I
Do you
mean,
change the
just-
fuse?
You have to change the fuse, but I mean, you gotta find out why did the fuse blow. So either that element got too hot, or something touched, or something
Something shorted out or went bad.
Something
So,
right.
if you go to a job and a circuit breaker's off or the fuse in a microwave is blown, do you just put a fuse in there and say, it runs for 2 seconds and walk out?
No.
You gotta figure out why did the fuse blow? A lot of times microwave fuses blow from all the door switches not being lined up or whatever. But the point is that a fuse is a safety, not a control. And when I use the word control, I'm talking about thermostat, switch, relay, parts that turn other parts on and off. They are controlling those parts.
Yeah, but if a customer circuit breaker keep jumping from the microwave, sometimes the circuit breaker get weak. The springs inside it.
Oh, it can happen. Yeah, I mean,
So it might not even be the fuse of the microwave. It could be the circuit breaker itself.
yes.
It's weak.
But in this case, this drawing would tell me that's in the microwave.
The fuse.
Because in most diagrams, you have arrows like this, and GE likes to put like this, like a quick disconnect, and they'll have a fuse here. So is that fuse inside the appliance? No. that this is where the power comes in. This is going to the power cord or in the customer's home at that point. So now that fuse is outside of the machine. So you have to know when I'm looking at the diagram. They very rarely show you anything outside the machine. Now that wouldn't be the fuse box in the house. That would be somewhere with a power cord, because if they put it on the diagram, it's related to the machine they're working on. It's not, it's like, if I'm working on this machine right here, it's not here on the wall, because they wouldn't draw a diagram, they don't know there's a fuse there.
So that would be like the little plug with the breaker on it, if they would put that on the.
Like the
drum.
GFI kind of thing, yeah.
Yeah, like, so if you plug
Yeah.
it in and too much.
Exactly.
it's pop.
Exactly. Got
Gotcha.
it? Good job. All right. Next two diagrams, I want to use a timer switch with a safety controlling the load. Now, your guys' paper didn't have 3 spaces like that. I made this diagram with 3 spaces because you only had a space to put 2 things. I need someone to come up here, Paul, and do this one right here.
What is that one?
This is, I don't know the
Timer
number,
switch?
because I screenshot it.
Safety?
Timer switch with a safety controlling any load. So you need a timer switch, a load, and a safety.
You got it, Paul, I taught you well.
Yeah, okay.
I taught you well, Paul, you can do
No.
it.
Taught me well.
Timer switch, the timer switch is this one.
Control. Time switch control with this.
The timer switch.
Okay, so now what kind of safety gonna use?
You
Did
can
we have a
put
safety in the
this,
last
you put a
diagram?
fuse, and you put a bulb.
You can look at your papers. The last, just the last one we just did. Was there safety?
This is safety. This is
Hey,
the,
this is what you guys gonna learn.
the control.
That's the control time switch.
No, this is the adjustment.
Oh,
When
that-
you do the 45, it's adjustment.
Get ready for the bottom one. Yeah, do that one.
Well,
I was trying to see
Which
what
one
kind
is
of safeties.
That one.
yeah, well, shit, you got this paper in your bag.
And you can use
Yeah,
this.
that's what you can see all the switch.
Yeah, that's what.
You use a breaker, circuit breaker, and a motor or something.
All right, thank you.
Remember.
Is this a good circuit?
Yes.
Well,
Well, what? Yes or no?
well, I trust Paul because his age and experience.
No. No.
Paul, how much you gotta pay him after class? Now, anybody else, is this a good circuit? Which one is the control?
The switch.
Switch.
Which,
Timer.
which switch?
The
Timer
timer switch.
switch.
Okay,
Switch it.
so that's not a timer switch.
No.
Which one's a timer switch?
It's
Which
just a
is a
regular
timer
switch.
switch? You got the circle at the top.
Need to be exactly both.
It need to be thick. He told me that you gotta be thick when, like your girls, Paul, thick.
That's what she said. That's what she said.
That's a timer switch.
Okay, all right. Bye
So
bye.
you're saying that's the control? Okay,
No, electrical company.
so we're gonna put this as control.
Yeah, but the safety,
You got your safety.
I don't see the safety there.
Yeah, I don't.
Okay, so what is this?
It's a heater.
It's a heater, so what is it?
The load.
It's a load? Okay, so then what is that?
It's the safety.
That's, he can use it as a safety, like a fuse.
Okay,
It's another
So
control.
if it goes,
It's another
so a thermostat can either be a control or a safety, like in a dryer. They, on the heating element, they have an operating thermostat and they have a high limit thermostat. The operating is what controls the heater, but the high limit is the safety. So that can be used as a safety. So we just put high limit. Okay, that's good. Now, if this same circuit was like this,
Better.
It still works.
As I said, it don't matter. It don't matter. It's going to do the same thing. Again, this has gotta be a 120 volt circuit because I have no control on this side too. I have safety on this side, but no control. So the thing is that, yes, they could be in different orders. Again, when you're looking at a machine and you're troubleshooting, understand that certain parts are in order the way they need to cycle or operate throughout a whole program cycle on the machine. Yes, sir.
No, I was just gonna say the control can be the last one, so.
Well, it could and it would function, but it wouldn't be
Then
safe.
you won't be safe, yeah. It'll be
Yeah.
always late.
Eves, I want you to do the same thing, put a timer switch, but different safety and different load.
He's asking a question.
Oh, Francois, you had a question?
Yeah, if we're doing timer switches, it's always gonna be labeled with the contacts, right?
I'm sorry, labeled how? You can go ahead and draw on it. Go ahead and draw your thing while he's asking me.
Like timer, the contacts on the timer are always gonna be labeled on that switch as well, right?
But labeled how? That's what I'm trying to get. Like,
Y, B, G, the.
well, okay, now, that label is the wire colors connected to that particular switch.
Yeah.
And that's what a diagram's supposed to do. A diagram not only shows you how power flows through all the parts in the machine,
What color
but they're
wire?
telling you what color wire connects these parts together. So when you're looking at a whole machine, you're not supposed to have 10 blue wires, because then you wouldn't know where the wire went on the other end. Because sometimes you see a wire going to a part, like on a refrigerator dispenser. You see it in the door there where you put your cup, but the wire goes through the door, through the hinge, through the cabinet, and comes out inside the freezer. You can't physically follow the wire. So that's why every wire has to have its own color code in the diagram. What's your step there? So what is this?
That's a timing model 2-speed.
And then what's that?
That's a load.
Yeah, but we want a timer switch. You don't have a timer switch, just a timer switch. Wait. A safety, you have that as an adjustable, so that's not a safety.
Okay.
Here, without it being adjustable, it's a safety, okay? And then
You want
the
that to
load,
set this
if that, what is that, a timer motor?
Oh, yeah, timing
We'll
model.
just put TM, that's okay, so these are the only two you have to correct, okay? So we'll go like this and we'll raise it. And so right now, wait, let me finish here, cause I gotta put the pen back. So we want a timer switch here,
Yeah. 40%.
okay? And then what we want is a safety here, but try to do the fuse, you know what a fuse is, right?
Yeah.
So do the fuse,
300-400. Except I don't,
that's close enough.
I don't have insurance.
So,
Not everybody's an artist, but you did your
I
job.
don't like it, it's gonna be too much.
Okay, so here's his timer switch. Here's his fuse. Not everybody's an artist. And that's his timer motor. But as long as he's got the principle, remember, I said the other day, you don't need to draw the diagram. You need just to be able to understand the diagram that goes with that machine. If he can understand the principle, I don't care if he can't draw, period. You know? That's one of the reasons why we use symbols as well, because not everybody can draw that well. If I asked everybody in this room to draw a light bulb, do you think you all can draw a better light bulb than me? But the point is, ChatGPT. Yeah, but the point is though, is that if everybody drew their own light bulb, like a pictorial, none of them would look the same. And someone might be able to look and not recognize it as a light bulb. But a light bulb that is a symbol with just like a hump and a circle, it's a lot easier for someone that's not very good drawer to draw that symbol. That's why we went to symbols. Because when electricians would wire homes or big buildings, they had to make diagrams for it, and half the people couldn't read them. So they had to, create a code and a standard that everybody follows, so that 10 years from now or 20 years from now, the guy who built or architect the building, he's no longer alive. Well, they need to be able to read the plans, how he wired it, so they could fix it. That's what this is on the appliance. Okay? I'm gonna finish this up. Yes, go ahead, Francois.
I was just gonna ask, I know there's thermal fuse, I know there's a fuse on the circuit board. Are there other types of fuses? Like, is it a lot of different fuses or just?
No,
the same?
there's either a fuse that blows on temperature,
Yeah,
a fuse that blows on current draw.
that's it.
That's it.
No matter what appliance it is.
A fuse is a fuse.
Okay.
It just opens up. Okay, so let me just draw them because we've already gone over an hour and a half, and I don't like making my lectures normally more than an hour. But let's go over this one and then we can discuss it. Combine the two circuits you created above into one diagram. So in both those circuits, you guys had timer switches in the last one here. So that's a timer switch. And then if I look here, one of them had a thermostat, one of them had a fuse. So I'm gonna draw the thermostat here. And then this one here, I'm gonna draw the fuse. And I had a heating element and timer motor. I had a heating element and a timer motor.
2-speed.
That's it. You guys should be able to draw that fast. Now, the next assignment that you're gonna get, I'll go over this last one in a second, is going to be a little bit more complicated. I'm gonna let you guys use your notes with all the different symbols on them, but I'm going to give you a paragraph. And I'm gonna tell you how to do it. Let me go over this one and then I'll give you an example of how this one, because this one's gonna be a little bit more tougher than what you did today. Okay? So create a parallel circuit using two different loads, controls, and safeties on a diagram. So we have two different loads and controls. So watch this. Let me think, trying to think, oh, didn't want that. What did I have here, a thermostat? No, I didn't have a thermostat, I had a fuse, I'm sorry.
Fuse.
I touched it and it just disappeared on me. Okay, I'll put a fuse on both of them. Is that a good diagram?
Bottom one.
The bottom one?
Yeah, because there's no control.
Well, I had a thermostat here,
Oh, okay.
adjustable thermostat, that's my control.
Oh, okay.
I'm sorry.
No, it's not good because the fuse.
Because
Electricity is
the
coming,
fuse come
current
out
is coming from the, on the other
But
side.
each circuit has its own fuse. It
What-
doesn't
What
matter.
I'm talking about, the current, it come from the left
Ah,
side.
so what would happen if the fuse went bad?
Yeah.
You could all-
so
but
you
it's
would
still-
I
have-
still have power at the motor,
Yeah.
which probably what blew the fuse, so this could end up blowing the breaker, right?
Right.
Very good, good catch. Okay, but is everything else working in the circuit? I put something there that we haven't drawn yet. Anybody identify it?
Those two fuses.
What you call it, motor?
Raise your hand, because y'all said something, nobody said the right answer
The
anyways.
link,
Yes.
the link between the switch and the.
Okay, so that's a dotted line, but what is it? Yes, Corey?
Well, I would say, it looked like you put a balance in there.
No, what did you say? It's a relay. Very good. Relay is two parts. It's a switch and a magnetic coil. So when I turn on this thermostat, I energize that coil. That becomes magnetic, pulls down on the switch, and turns on the motor. These are relays. This is called a contactor, and it's called a relay from a central air. On the bottom here is a coil, it's a magnet, 24 volts, and on the top are the switches, and it pulls the switch down. The switch goes across, it just pulls down. Now in here, there's switches, and you can actually see the coil on the bottom of this one.
Yeah.
These are relays.
Okay. But only.
That's how it looks on the diagram. Yes, there is a relay on your paper, just like you told me the other day that the coil wasn't there. Yes, sir, you have one question?
How did that circuit work again? The one that you
Okay,
showed?
so, it's an adjustable thermostat, that's this. Has an off position.
Right,
I go like this, it's off.
right,
So I go here and I turn it on. I close the contact.
right.
That is that switch there. When I close that contact, this energizes.
Right.
And when that energizes, that become magnetic, and the dotted line means they're mechanically linked and pulls this switch down. So now this energizes once that one's working.
Okay. And if any of it gets too hot, the fuse will let you know that it's too hot and cut power off.
No, once it reaches temperature, that opens up, that coil don't get power, turns this motor up. This is how this works right here, the thermostat for your AC.
Yeah.
Thermostat is this adjustable thermostat. It sends power to the coil, which is outside, and turns on the compressor. And when it gets cold enough in here, switch opens, turns it off.
Okay.
That's how it works.
Right.
But we're using a thermostat in a low voltage circuit, not in this diagram, but in a central AC.
Okay.
Okay? So that's it. You guys got a little bit left. Go ahead and finish your